Hi, everyone. I'll try and share my screen. As was so well said, I've been working together with Google and Mozilla and Meta and Apple and everyone else involved in the W3C. It's working in the private ads technology community group to see if we can standardize a new, more private way of measuring advertising that doesn't involve tracking. So this presentation is sort of an update of what's been going on. So I would say that standards moves pretty slowly. I've been working on this for 4 years now, but I feel that we're making progress and we're getting a lot closer. And I can see real progress made this last year. Here's sort of a brief history of the events that have happened over time. It really got kicked off in 2019 when John Willender from Apple made this blog post introducing privacy-preserving ad click attribution for the web. And that was the first public proposal for how to do privacy-preserving ad measurement without tracking. Google immediately followed up with a different way of doing things that is the whole Google Privacy Sandbox. That blog post came out in August 2019. Their proposal for how to do ad measurement is the Attribution Reporting API, or ARA. And then following up, my friends at Meta and I collaborated together with the folks at Mozilla, and we co-proposed a third idea called interoperable private attribution. We proposed that back around Jan-Feb of 2022. Martin's post on the Mozilla blog is from February 8th, 2022. We've been discussing it, and very exciting recent development is just this August, Luke Winstrom, also from Apple, has come up with Apple's second proposal. Sort of all of these things are building on the previous proposals, taking the good ideas from the things that have come before and building upon them to try to make better and better ideas. So it's really exciting to see Apple sort of taking the feedback from the community about things that people didn't like about the original proposal and trying to come back at it again with a secondary proposal. It doesn't have like a catchy acronym yet. They called it Private Ads Measurement. So I guess like PAM is maybe the acronym, but Martin's trying to get us to call it Apple's Aggregated Advertising Attribution API, or which I think is pretty hilarious. So, we'll see if we can make that one stick. Basically, this is exactly how standards bodies are supposed to work, to have all these different companies coming together with these smart people, sharing ideas, building, riffing off each other, taking ideas from each other's proposals. And it makes me really happy to see this. It's really awesome to see companies that don't normally get along together, working together through a standard setting organization to try to collectively solve this common problem that will benefit everybody, web publishers, advertisers, and the people who use the web to give them a more private browsing experience. I love the way that all the proposal authors always cite all the preceding works and give credit to the people who they were inspired by, and the way that everyone's trying to improve one another's proposals. So I'll give some examples of that with IPA soon. And the really cool thing is that if we are able to align and standardize on a recommendation that we make, the W3C makes sure that there's no IP infringement issues. So everybody can use it, and there's no patent worries. So the W3C is a consensus-driven organization, which is why it moves very slowly. But we are making some progress. So the really exciting thing that we have reached consensus upon across all those big players I mentioned, and the other participants, is that there can be some kind of server-side component to assist with this aggregate measurement problem. And we believe that it'll use some kind of privacy-enhancing technology to protect privacy. It's really hard to come up with a good solution if you try to do everything on the client. The only one of those previous proposals that does everything client-side kind of is PCM. But at some point, information has to leave, right, and go to some kind of a server. And that already produces problems and risks and privacy problems. It's actually probably more private to have a server-side component that facilitates the collection, aggregation, and anonymization of this aggregate data. So there's a couple of different privacy-enhancing technologies that we're evaluating. The two main candidates are trusted execution environments and secure multi-party computation. And it feels like we're converging towards secure MPC. Google's original proposal was based on MPC before they pivoted it towards TEE. IPA, our proposal together with Mozilla, that's an MPC-based proposal, and Apple's newest proposal is also an MPC-based proposal. So we have at least 2 out of 3 of the current proposals all being MPC-based. And then when it comes to output privacy, we've reached consensus that differential privacy is a really good option when you're in a zero trust environment, which is kind of like the situation that we're in here on the web. The browser vendors do not trust advertisers and they do not trust publishers. And if you don't put any trust in the people who are calling your API, to ensure that the outputs of that API can't be linked to individuals, adding differentially private random noise is about the best idea that we all have. So the exciting thing is that if we do have some kind of server-side component doing the aggregation and adding this differentially private random noise, you can centrally apply this DP noise. So basically, instead of adding noise to every single record of data that's going in, which is called local DP, you can sort of aggregate it all and then add a little bit of noise to the sum. And the amount of noise you add is proportional to one user's contribution. So the cool thing there is that you get a much better signal to noise ratio. The amount of volume of noise is small compared to the volume of the signal if you're aggregating over large numbers of people. So centrally applied DP is where we seem to be headed with both Google's ARA aggregate approach, IPA, and Apple's new proposal, all using central DP. We're also moving away from these sort of hard-coded entropy limits that don't provide any form of like academically rigorous privacy protection towards differential privacy as the mechanism for privacy protection. And these random time delays that were part of these earlier proposals that seriously undermine utility without providing really particularly robust privacy protections towards like just zero leakage by design, where you, for example, the browser emits something at a known time, like exactly at the moment that the event occurs. So the timing has no information. So we have this one really big critical architectural decision that we have to make together, which is where does the attribution happen? So you have, people are seeing ads and then people are later making conversions, say buying things. Where does that linking up happen of, oh, yes, before this person bought this thing, they did see an ad for that. And that's the one that will get credit. So there's 2 different schools of thought. Google and Apple, their proposals both involve that attribution happening on the device itself, whereas IPA involves that attribution happening off of the device. So this is like a really, really important architectural decision about how we design this system, and many, many trade-offs flow directly from that key decision. So what we're doing after our last meeting together in Seville about a month ago is we're going to try to make the best in class of both proposals and sort of see what the best we can do with each design. So Google's ARA and Apple's can probably be combined into sort of a best in class on-device attribution proposal. So we're going to work together to sort of take all the best ideas from those things and merge them together and make the best version of an on-device attribution that we can. Now, there's some downsides with on-device attribution. In particular, my concerns are, firstly, what can we do to mitigate fraudulent clicks or accidental clicks from stealing credit for conversions from legitimate publishers? So in both of these designs, the downside is that when this attribution happens, it sort of like eliminates the ability of these other impressions or clicks to receive any credit, because it's like a giant centralized thing. So I don't want to see the internet turn into this sort of cesspool of everyone trying to make these trick-to-click advertisements to steal credit from other websites. The other concern is if you do everything on the device, you actually have a whole lot of client-server communication going on, potentially like megabytes of information going back and forth between clients and servers, because you have to ship a lot of information down to the device and then ship it back again. So this might wind up being a problem for low bandwidth connections. But good news is we have some good ideas there, and we're looking forward to working together with all these other folks in both the IETF and the W3C to talk about those ideas. We're also going to try to make the best-in-class off-device attribution proposal that we can. So since IPA is the only off-device attribution proposal, it's up to us to sort of improve on the areas where people have cited concerns. So Google has cited the concern about, will it scale? The Google Ads team, finally, after much cajoling, was willing to give one number, which is sort of their target of what they'd like to see it scale to, which was 200 billion events per day. That's an outrageously huge number, and we have our work cut out for us, but we're going to do our best to try to scale up IPA and demonstrate that it can scale to Google scale. We're working on this new version of IPA. I'll talk about the versions of IPA in a second, and hopefully we're going to be able to address this. Apple has cited this concern about user transparency and auditability. They really would like an API where a single user of a single Apple device can go and understand exactly how is my data being used with some kind of an interface that tells them something about what's going on. And that's like potentially something that we can do as well with IPA. So Martin has some good ideas. He's working on some write-up of this, and hopefully we'll be sharing that soon with the W3C. So let me just give you a little bit of a history of our IPA proposal. We initially, like I said, launched this back in January of 2022. And the original design was based on like an OPRF, an oblivious pseudo-random function of this sort of match key, which would then be shuffled such that you wouldn't be able to sort of link between the inputs and the outputs. Unfortunately, we found this attack that violated our privacy and security threat model. And so we had to go back to the drawing board and try to improve the design of this system. So by June of that year, we came up with a new approach that had zero leakage. There was no sort of side channel information leaking out of the system because we did everything in MPC, including sorting all of the events. Now that's a pretty expensive thing to sort, potentially 200 billion events. And sorting is sort of a log, an n log n sort of thing. So that's like where our current bottleneck is. So this year, what we did is we did a trial of this IPA technology together with the Singapore privacy regulator. So the Info Mediacom Development Agency, IMDA in Singapore, has this privacy enhancing technology regulatory sandbox where they invited companies to come in, trial new interesting things that use privacy enhancing technologies, and the privacy regulator would comment on their opinions about how this interacted with Singapore privacy law. So we took them up on that offer and we ran this trial. So this was a really good opportunity to sort of like test drive this thing in a more real world scenario. So we found 3 helper parties to operate this multi-party computation for us. And those were Akamai, Nanyang Technology University, and Cybernetica. So that was really cool. We found a lot of bugs. We improved the code base dramatically. It was really cool to work with all those folks who were awesome and super helpful. And the Singapore IMD was fantastic. They basically PM'd the project. So what we found was it took about 8 gigabytes of inter-helper communication and about 6.5 hours to run a 1 million event query. Now, there's lots of things we can improve here. This is sort of single core, single threaded. So we need to go parallelize our code base. And it's just like some technology things we can do, but also we've gotten a lot of really good advice about how to overall improve the architecture for much more horizontal sharding capabilities. I'll talk about that in a sec. So now we're working on the newest version of IPA, where we're sort of back to the original design. Once again, it's based on an OPRF of the match key and a shuffle, but we found a way of mitigating that original problem. And the way we can prevent this attack is by having the device who's generating these encrypted match keys enforce like a sensitivity bound, where it keeps track of the number of these encrypted match keys that it's given out. And once it reaches that limit, it just stops giving you new ones. It gives you encryptions of garbage, like random numbers. And when we have this sensitivity bound, we can get a differential privacy guarantee by adding a random number of dummy records. So this has been a really exciting collaboration. And this is one of the things that makes me most excited about working together with all these folks through the standards body is mostly this proposal comes from Google researchers, Mariana Rakova and Philip Schupman, who had this idea when you have this sensitivity bound, you actually don't need to add that many random dummy records. And the really cool thing is the number of dummy records is not a function of how many rows of data you're doing. So for example, if the device enforces a cap of 100, even if you pick like super conservative DP parameters, like epsilon of less than 0.1 and delta of like 10 to the negative 7, you'd only need to generate, in expectation, less than 1 million dummy records. And that's a fixed cost. So if you're running a query on 1 billion or 10 billion or 200 billion records, it's the same number. So as a percentage of the query size, this becomes smaller and smaller for large queries. So this potentially gives us a way of sort of forking. And for very small queries, you don't need to do this. And for really large queries where you need to horizontally shard, we can pursue this approach. So this is going to be a lot faster and cheaper. It eliminates this need to sort by the match key in MPC. That was that n log n thing I was telling you about earlier. And it makes for a much cheaper MPC circuit. And we can also just shard this across many physical machines and multi-thread it for massive latency savings. So that's what we're working on right now. I'm super excited. Hopefully we have some variant of that working in early Q1. And again, this is exactly how standards bodies are supposed to work. All these smart people coming together, sharing ideas publicly with no IP infringement, and trying to help each other out and build on these ideas and see if we can collectively solve this problem together. So just sort of stepping back for a second, if we want to have this new private future where advertising is still a part of the internet and publishers can still offer, free services that are supported by advertising, but if we want to get rid of all tracking, then there's sort of these 3 major use cases that someday, ultimately, we're going to have to figure out how we address them. You need to be able to measure ads for advertiser reporting or just calibrating your system or comparing 2 versions of, say, 2 ad formats. You need to do optimization. So you need to understand how should I price each ad impression. Pricing ad impressions well, not overcharging or undercharging, is a huge part of getting good ROI. So we need some kind of optimization, which today is based on ML. And then you need some kind of targeting, like you need some way of selecting a relevant ad to show in the first place. A lot of these things are all going to break when we slowly see a more private internet evolving. So what we're discussing right now in the W3C has been largely focused on measurement, because that's where we have a lot of consensus that everyone thinks, yes, aggregate conversion measurement seems like a use case that we would like to find a new way of supporting. Optimization seems like the next potential place that we might be able to make a little bit of progress, because the technologies that we're building for measurement could potentially be adapted for optimization. Currently, targeting is not really in scope, and I don't have any particularly good ideas of how we can use privacy-enhancing technologies to solve that problem. So for the moment, we're not really particularly focused on that. So let's talk about that ML use case really quick here. So what are we doing with ML? We're trying to find some sort of statistical correlations between features and the likelihood of a conversion. So there's sort of 2 paths of how you could approach this with privacy-enhancing technologies. The most straightforward one would be what we call sort of noisy labels. And I'll explain what I mean by that in a second. The much more difficult path is to actually move machine learning into secure multi-party computation. So noisy labels. This is more of like a philosophical question. The question is, if we design this standard, should aggregation be a requirement, or is differential privacy alone sufficient? So what do I mean? Imagine you had an API that gave you reporting at a ad click or ad impression granularity. And what it's telling you is like a 0 or 1, like did this ad lead to a conversion or not? Well, you can make that differentially private with what we call random response, where you pick some probability P, let's say 10%. And then 10% of the time, rather than returning the true answer, like 0 or 1, you return a random answer. Randomly just choose either a 0 or 1. And then with the other probability, you return the correct label. So let's go through this. Let's say I click an ad, and then I go to some website where maybe I made a purchase. Now the API returns the number 1. What do you learn from it? Well, did Ben actually make that purchase? Maybe he did, and maybe he didn't. And that's what differential privacy sort of gives you here. It gives you what we would sort of characterize as plausible deniability. You can say nope, I didn't make that purchase. And no one can say that you're wrong. Like it's possible that the API rolled that random 10% and randomly returned a 1. So how happy are we philosophically with this sort of approach to protecting privacy? The answer is like, it really depends a lot on P, like that random chance. So let's just go through a little bit of math really fast here. So take Bayes' theorem, which tells us, what is the probability of something given some other information? So what's the probability Ben like actually made that purchase given the fact that the API returned a 1? Well, you can sort of plug in the numbers into Bayes' theorem, and what you get here is this number I've highlighted in green, 37.3. So in this case, let's assume that like purchases are fairly rare. Only 2% of the people who click this ad go and make a purchase in this made up example. In that case, your original guess was, well, there's a 2% chance that Ben made a conversion. And then after you get this API response of a 1, you're more confident than you were before. How much more confident? Well, you're now only 37% confident. So there's like a 37% chance Ben actually made the purchase, and like whatever, a 62.7% chance that he didn't. So the epsilon differential privacy way of looking at this says that's an epsilon of about 3. So you could make it a lot more private if you made the random chance about 50%. So 50% of the time the API returns garbage, right? In this case, receiving an API response of 1, you would be like really not very confident. You'd say, even though the API told me a 1, like I only know with 5.7% confidence that Ben made this conversion. That, from an epsilon differential privacy standpoint, is an epsilon of roughly 1. So my conclusion from this is sort of like, if you want to design an API that gives out granular reports like this about single events, and you still want to be like really uncertain and not really learn things with great confidence, you're going to have to introduce a lot of random noise. I mean, if 50% of the time you're returning a random label, you've introduced a lot of random noise to that thing. So like we talked about this in the PAT-CG. Charlie from Google has been trying to convince everybody that this is the path that we should go on. He's been extremely eloquent and very convincing, honestly. The things that we sort of understand now is that you can't actually really prevent the measurement of single events. You might think to yourself, well, just have a requirement that every query has to have at least 100 events in it. Sure, but you just run 2 queries, a query with 100 events and a query with 101 events, where the only difference between those is 1 person, and you just subtract the 2 numbers, and then there you go. The difference between those 2 things, you've queried a single event. And there's like lots of other attacks and hacks on this thing where you sort of finally come to this conclusion like, wow, I can't actually prevent this. The only backstop we have available is differential privacy. That's the only one with like a strong, academically rigorous privacy protection. So like, what is the participant's comfort level with intentionally designing an API to support the measurement of single events, rather than it being like a side effect of if you sort of did these differencing attacks? I expect that some of the participants are going to try to seek a very conservative value for epsilon, which would sort of seem to make it not particularly valuable. So you can see a little snippet there. This is one of the things that we've captured in our GitHub repository, where we try to write down the areas that we do have consensus. I'm not going to read it to you, but basically, like, it depends on epsilon. It's really like our consensus that you're going to have to think really hard, and probably we're not going to agree on what epsilon should be. So the alternative approach, that sort of the other way that one could potentially try to approach learning about the correlations between these features and conversions is, if you think about it, what you're trying to learn is really an aggregate statistic anyway. So getting these noisy labels and doing normal machine learning in the clear is one approach. But you could also just say, well, I'm trying to learn an aggregate statistic. Let's just design a multi-party computation to directly learn that aggregate statistic. So that's hard because like machine learning is often really advanced and complicated, and it's already expensive to make it happen in a computer. And doing something in MPC is like 100 times more expensive. So, I think what we're going to do is just start with something really basic, like logistic regression. This is not fancy, it's like not a deep neural network, but it is used in production by various ad tech companies. It's not terrible. For certain use cases, it's probably okay. And the cool thing is we actually can implement this efficiently in MPC. So Criteo has been publishing lots of research into logistic regression based on noisy labels. I'm hoping for us to start implementing logistic regression in MPC so we can start measuring like how expensive is this, like how long does it take, how useful is it? And it's technically possible to do logistic regression even with Apple's proposed approach, which is based on this MPC called Prio. And you can do logistic regression in Prio as well. So this is potential future direction that we're going to be exploring in the W3C. Okay, I don't know how many minutes I have left for Q&A, but I was told to leave some time for Q&A.
Thank you, Ben. A round of applause. So we only have a few minutes. Big topic, series of topics. So let's go ahead and get started. You want? Yeah.
Hey, thank you. So you mentioned centralized differential privacy. I was curious if you had any protections in place against the, because basically the clients are sending unmodified responses and then trusting that the server will apply the noise correctly. Is there any protection against maybe the server decides not to apply the noise?
Yeah, definitely, of course. Like, this is a zero trust environment, so we don't trust anybody to do anything. So there's a couple of different approaches. The most simple way is, since this is a multi-party computation that's being operated by a couple of different helper parties, you can just have all three of the helper parties, or in Apple's proposal, it's like a two-party MPC, but both of the two both add noise. That way, if one of them is malicious and they choose to not add the noise, then you still have noise from one of the other parties, but like half as much as you expected, or 2/3 as much as you expected. The alternative is you actually take the generation of random noise and perform that in MPC. For example, like with like a coin flipping algorithm to generate like a binomial distribution. That's much better because then we can make a maliciously secure MPC where the parties definitely added this random noise. And if someone tries to deviate from the protocol, the other honest parties can abort. So in all these designs, we can have confidence that as long as at least, n of the parties are honest, we still are certainly adding the differentially private noise.
Awesome, thank you.
One more, maybe. Yeah.
Hi, Ben. I just wanted to ask, who chooses the parties that take part in the MPC?
Great question. One presumes that it would be up to the browser vendor themselves to decide who they are confident in to protect their users' privacy. So this is probably going to follow a model similar to certificate authorities, where each browser basically decides who they trust to be a certificate authority. And there's this governance model around that called the CA Browser Forum, where they basically get together between the browsers and the certificate authorities and come up with like, what are good practices for being a certificate authority? Like what should you do? And then they audit them routinely. And if they aren't following those practices, they kick them out and they remove their public keys from browsers. So one imagines that we would need a similar governance system in place that has some kind of like legal contracts between browsers and helper parties, where the helper parties are promising to correctly run the protocol and to not deviate from it with some sort of legal consequences if they do, and some kind of an auditing regime and some sort of best practices. But this is something that we really still have to work out. But potentially we could imagine a world where like the choice of helper parties available in Safari differs from those available in Chrome because they have sort of different bars of who they're willing to trust. But one thing that will be certainly true is it's not just these are the set of people who can run a helper party. It will be these are the combinations. So in IPA, it's these triplets of 3 parties. It would be what are 3 parties that we trust to not collude. And so, for example, like there might be 2 parties that are both great and you love them both, but they're both running on AWS. And so you would really rather not have 2 of the 3 parties running on AWS because it introduces like a single point of failure where, I don't know, if AWS is compromised or something by a hacker, then like 2 of them are now vulnerable. So, it'll probably be like these are specific helper party networks that each user agent trusts to protect their users' privacy.
With the certificate authorities, they have a very clear incentive on doing that, the authorities themselves, so they earn from selling certificates. What's the, why would any party decide to become a helper in this, in this scheme? So what's their financial incentive for that?
Yeah, we envision that advertisers who want to run queries have to pay for them. Someone has to foot the bill of running the MPC, and presumably it's the people who are benefiting from it. So we're imagining that this would be something where you'd pay for usage, and the helper parties would presumably have some profit margin on top of that. So if you take the advertising industry globally, digital advertising is probably what, $1 trillion industry or something. If you take 1% of that and imagine that advertisers are going to spend 1% of their ad budget measuring their queries, that's a really sizable business all of a sudden. And if that's being divided amongst only the sort of accredited, authorized helper parties who have earned trust and have passed audits, then that provides a clear financial disincentive to losing your accreditation, because then you lose access to that market.
Great. Thank you very much again, Ben. Let's hear it for him one more time, everybody.